Hello and good morning to our webinar about trigger, gas standard, and gas type. Welcome to everyone. I will present the webinar, and lovely Janessa and Stephanie are directing this webinar and take care of your questions if you have some. So, first of all, I want to repeat again what functions you have for the GoToWebinar tool. So you have 4 different chances to interact with me. You can hide the panel if it's disturbing to you. You can put it to full screen. You can raise your hand for the end. That means to see or to ask any question at the end. And you can enter some questions or comments if you have some during the session, and Stephanie and Janessa will take care of it. So, my name is Marco Kellenberger, and I work as a product manager at IMT Medical in Switzerland. Maybe you can hear it because of my accent, that I'm not English, I'm Swiss, and I take care of all of our biomedical products, including test lungs. So, today I will show you, or I will present the topic on our brand new gas flow analyzer, the Cydrex H5, which can display waveforms, has a multi-touch display, Wi-Fi, and it is a all-in-one device. As you know from our first session, we have the possibility to build in apps which should help you to perform the testing easier than before. So today's topic is, first of all, I will start over with something, probably the simplest part, which is gas type. Then I go for the gas standard, which is the main session. And finally the trigger, and at the end, you're free to ask any question you like. Gas type. We have different type of gas types built in the Cydrex H5, also Cydrex H4 and the PF300. But this is actually in the whole market almost the same. That means most of the devices can display different kind of gas types, but we have some speciality, such as we're able to display or measure air O2 manually, air O2 auto, which includes O2 measurement with the O2 cell. We can set it up to heliox, nitrogen, and mixtures such as N2O2 and the CO2. The PF300 has something special, which is the user-specific gas type. So you are able to design your own gas type you would like to measure. So I give you an example. Why is this important? So it is important because if you set the wrong gas type, and I would suggest if you once have to perform any gas measurement, you first of all make sure that you set it to the correct gas type. It's usually simple because most of our users, they basically use air or air O2 mixtures, usually measured with the O2 cell. So you're good. But if you do something special like CO2 or heliox, make sure that you set it correctly. And there's one example. So if we set our analyzer to measure air, but instead we measure O2, the difference is not that severe. That means we're 0.1% too high. But if we go for CO2 instead, it can have approximately 35% difference. So I shortly want to show you, if Janessa could switch over to the second camera, how does it look like on the Cydrex H5. It's very simple. That means you basically swipe over, go to flow, then long tap, and there is the whole list of different gas types. By simply choosing one of these, I go now for air, since I use my ventilator with air only. Confirm it, that's it. So it's pretty straightforward, but you just have to consider it. The same with the PF300, you have to go to the settings and set the correct gas type. No big deal. So that's how it looked like on the Citrix H5, but you already saw it on the video. Gas standard is usually a big discussion for me. So I get a lot of questions about gas types. I want to start over with a definition. So the definition we put together is this one. It looks pretty complicated, but I will make it easy for you. So the gas standard is a standard condition which is used to compare, for example, a measured flow or volume from the ventilator to the analyzer. So basically, this is all about it. If you go for example, for our ventilator, which is actually the most convenient one for me to show you because I know it very good. You just go for the gas standard AP21. So you also have to make sure that you display the same gas standard. So why is this important? The gas standard actually consists out of 3 different conditions. So that means pressure, temperature, and humidity. In our analyzers, we do have approximately 17 different gas standards to choose from, which can be pretty complicated. It was for me as well as I started over, but I can give you some hints during this presentation. So some examples. For example, if we go for an STP, so the standard conditions United States of America, this is defined with 760 millimeters of mercury, 70 degrees Fahrenheit, and no humidity. So the gas flow or volume is calculated on this standard condition. Similar or same for the AP21, but some changes. That means we measure the current ambient pressure with the device. It's normed to 70 degrees Fahrenheit, and also the current measured humidity. So with these 3 inputs, we are able to define. Why does this matter? Basically, I'm sure most of you know about it, that if we have hot gas, it has a bigger volume than cold gas, which you can see on the left-hand side in the presentation. That means if we do measure a gas flow or a volume, which is hot, it has a bigger volume. So to make sure that this is normed for both devices to the same, we have to make sure that temperature matches. Same with the pressure. So if we have a high pressure, the same amount of air molecules can have different volumes. So also here we have to make sure that the pressure is the same. Good for you guys, if you use IMT Medical's flow analyzers, they are all temperature and pressure compensated, and if you set just the correct gas standard, you're fine. A smaller influence has the humidity. So if we consider having a balloon, as you can see in the presentation, with approximately, theoretically, 100% humidity and 400 ml, it has this volume. But if we take out all the humidity, the balloon shrinks to 392 ml. So also the flow analyzer, or the PF300, which is the same, has the possibility to measure humidity. I want to give you an example. So let's consider that we have a ventilator and a monitoring device. They are showing on the monitoring, you see that the VTI is, the inspired volume is 620 milliliters with a tolerance of 6%, and the ventilator is delivering 540 milliliters with approximately 10%. So you could stand in front of this bed or in front of this device and think, is this the same or is it not? So this is basically the task now. As you can see on the left-hand side, the bars, they sometimes match, sometimes not. So I set up together with Stephanie and Janessa a poll, a simple one, don't be afraid, and you can answer. So is the VTI the same? Yes, no, or it depends on the gas standard. If you want to choose one of these, then we get some results soon. I see that some of you already have chosen one of these three. Don't be afraid. I will not judge you for that. Just go for it. And most of you guys already voted, so let's have a look. So as you can see, most of you guys are right. So I will show you the answer. It depends on the gas standard. Correct. I have to admit it was simple for me, at least, to set up. But honestly, if you go to this device, you always have to make sure that you know on what gas standard the volume or flow is measured. So if you consider that the ventilator is delivering the flow on ATPD and the monitoring device is on BTPS, it has a difference. So if we calculate the ventilator's volume to BTPS, we go to the same range as you can see on the left-hand side. So it matches, but it depends on the gas standard. So if I usually get a question, and this is a hint which I really suggest you to use, but it's very helpful. We do have all of our gas standard in our service manual or user manual, and you're able to see what kind of gas standard is there, and as well what kind of definition does it have. So if Janessa would kindly switch over quickly to the second camera, I can also show it to you on the Sidewalks H5, which is also able to show you this information. If you go to Settings, Measurement, Gas Standard, I take my brand new yellow pen here for the MR ventilator. You can see the pressure, temperature, and humidity of this gas standard. So basically, why is this important? Not all of the manufacturers on the market use for all abbreviations the same settings or properties. That means if I usually get a question, I do the following 3 steps. And if you follow these steps, you're fine. So let's admit that we know that the gas standard we need to measure uses the current ambient pressure, current temperature, and 0% humidity. But we do not know what kind of gas standard we have to set up. So first of all, as you can see in the presentation, we have 4 choices, but this is just an example. There are plenty of more in our devices. So it can be one of these 4. If we go for the second step, like we go for the temperature, we only have 3. And finally, if we also consider the humidity, we go for the solution, which is ATPD in our case. So this means if you once come to a device and you have to choose what kind of gas standard you would like to use, just go there and take these 3 steps and you're good. So I've already showed you that one. You also can have quick access if you go to the edit mode at the Sidewalks H5. I will not go into detail of that. So you also can choose the gas standard and gas type at the PF300 by just setting it. It looks like that. At the end of this presentation, I give you some practical input of 2 devices, Traeger and Heinen Löwenstein, for gas standard and gas type, and trigger. So this brings me to the triggers. Triggers is also one important thing, but why is it important? I do not also get lots of questions of gas standard. I also get lots of questions regarding triggers. Why do triggers matter? That's the next topic. And I will sum up all my inputs at the end, so you have the chance to get it again. So we have 3 preset triggers in all of our devices. That means we have an adult trigger, we have a pediatric trigger, and we have a high frequency trigger. So they are slightly different, excuse me. So these 5 parameters, let's say that, define this trigger. So if we go for the standard adult trigger, we always take the internal high flow channel to measure where the trigger is set. We have a start condition of +3 liters per minute with a rising edge, and we have a stop condition of -3 liters falling edge. We have a delay. What is a delay? I will explain it later to you. And no base flow at all. So let's start over. Why is it important to have triggers? A trigger helps our flow analyzers and measuring devices, ventilator testers, to define, for example, the breath volume, IE ratio, and other ventilation parameters. So they are used to define and measure, calculate ventilation parameters. So if we consider regular ventilation of a ventilator, you see this in my presentation. We have an inspiration and an expiration. So that means we have a start condition and a stop condition for each of these phases. To define this, we need to know where does it start and where does it stop. So first of all, we have to set a trigger level. It is important to set the trigger level at approximately that level, as you can see on the left-hand side or on the bottom in my presentation. So we have to define a start condition and a stop condition at that part of the ventilation. So with this is the first step to set. Then, to tell the analyzer where does it start and where does it stop, we have to define, is it the rising edge? So is the curve increasing or an increasing pressure or flow, or is it falling? So usually the start condition is the rising edge and the stop condition is the falling edge. So with these two information, we are already able to tell most of these information, which means we're able to define the ventilation parameter. Trigger delay. Trigger delay is, let's say, not often asked, or mainly people do not care about it, but it can help you to measure correctly. So let's say we have this kind of ventilation of the flow. Have a look at the flow. We have this small spike there at the beginning. So what does the delay do? The delay makes sure that only a breath is detected. So in case we have a spike like this on the left-hand side, the analyzer does not count it as a inspiration, for example. Why is that? Because the trigger delay, let's consider it 60 milliseconds, waits after the start condition is set 60 milliseconds and checks if the condition is still valid. So on the left-hand side, there is no triggering at all, or it is reset because after several milliseconds, the spike is over. So the analyzer is able to tell there hasn't been any inspiration at all. But on the second curve, or the inspiration, the regular one, as you can see, the condition is still valid after 60 milliseconds. The condition is higher than, or flow higher than 3 liters per minute, for example. So in this case, the calculation is displayed. So one question I usually get is, but if I set the delay time too long, does it mean that we only measure after 60 milliseconds? No, the calculation starts at the trigger start, but it is displayed only after the delay time. So we're able to set pressure trigger or flow trigger. You can choose it regularly. And I want to come to one of the last topics, which is the base flow. So what is a base flow? A base flow is a constant flow flowing through the inspiration limb and expiration limb, which sometimes can have an effect for the measurement. So what happens? The flow curve is increased to a certain level, and we have to consider that we only measure the dark blue part. So with the information of the base flow in the trigger settings, we're able to define this. So the practical input, to sum up, we have to, for example, if we do check a Draeger Evita XL, it runs on a gas standard, very important, BTPS. You find this information in the service manual. You should use Air O2 Auto. Most of the units are, or the pressure units are in millibars and liters per minute, and the trigger adult fits in most cases. If you go for the Hein-Löwenstein Leon Plus, rather complicated device, it has different gas standards. So you really have to take care for each test to check if it is ATP or this other standard 0, 10, 13. The gas type has to be set on air and 100% O2, or actually it's O2 only. And the units is millibars from software 384, but before it was, I think, centimeters water or something. I'm not pretty sure, but I think it was centimeters water. Trigger adult fits as well.